This is problem 8 from the review sheet. Problem 8 references problem 13 from the chapter 8 review. It says an instructor summarized his student ratings, scale of 1 to 5, in the following probability distribution. So if the response had been excellent, a value of 1 was given to that response. If the response had been good, a value of 2, average, was given a value of 3, fair, given a value of 4, poor, given a value of 5. So then those responses and the number of responses in each of those categories was not given as raw numbers as to how many there were, but those raw numbers were converted to a probability distribution. So if there had been a total of 30 responses, then when the number of them that were excellent responses was converted to a decimal value, it came out to 0.2. So that would have been what? If there were 30 responses, it would have been what? 6 of them would have been rated as excellent. So rather than having the raw numbers, the professor converted those to probability figures or percentages. So in other words, 20% of the responses were an excellent response. 32% were a good response, and so on. So again, we have a probability distribution. And the question is, what is his expected average rating? So again, we're looking for expected value. What's his overall average rating? Was he overall rated as an average? Or, if his rating was somewhere between 3 and 4, he would have been rated between an average and a fair instructor. If his overall average was between 4 and 5, like 4.8, then he would have been rated overall as between a fair and poor, and even much closer to a poor instructor. But if his overall average is 1.2, then overall he was viewed as being between an excellent and a good instructor. So we could calculate that overall expected average, that expected value, by again taking the product of the value, the numeric value, times the probability, and summing those figures up. So 1 times 20 hundredths is going to be 20 hundredths. 2 times 32 hundredths would be 64 hundredths. 3 times 21 hundredths would be 63 hundredths. 4 times 15 hundredths would be 60 hundredths. And 5 times 12 hundredths would also be 60 hundredths. So if we add those figures up, those are his overall average rating. So we've got 20 hundredths plus 64 hundredths plus 63 hundredths plus 60 hundredths plus 60 hundredths again, for a value of 2.67. So that was his overall average, which tells us that's between 2 and 3, tells us that the students rated him as anywhere between an average and a good instructor, and leaning a little more towards average. If it was exactly halfway between, it would have been a 2.5. So he really leaned towards being, as far as the students were concerned, rating him as an average instructor. And so again, we can use this expected value idea to summarize the information here and get an overall average, a long-term average, we could maybe say. That's what expected value is.